Okay, so now we've talked about a whole bunch of fun stuff, and now we're going to start combining functions. I don't think you need to write this down because you've done this before, but adding two functions, also known as combining like terms, adding and subtracting functions, multiplying functions, FOIL method, that kind of stuff, multiplying and dividing functions shouldn't be a big deal, correct? Correct. And when you put those two functions together, you get something called a composition or a composite function. We're going to focus more on this guy, f of g of x, which can be written as f of g of x. So two ways to write the same thing. Don't get a multiplication symbol confused with an open circle. That can be quite a destructive thing. You understand what I'm talking about? This is the audience participation part of the program. Yeah. Yep. Don't get this confused with that. What is this? Multiplication. What's this? Which one am I putting into which one? G into F. Correct. You go from right to left. You put G into F. So we did things like this. Go to the function wherever you, that's a 2. Wherever you see next, put in a 2. Now the only thing that we're doing different is instead of putting in a number, we're going to put in an entirely different function. Question in the back.
On the homework, will they be written like that, or the way just above it where it's?
It depends on whether or not I'm feeling saucy. Sometimes I'll write it like that. Sometimes I'll write it like that. You should know both. Okie doke. So, let's do those two. We've got f of x defined as 2x minus 3 and g of x defined as cosine. Tell me what is f of g and what is g of f? Question over there?
Is that Treat Tuesday?
Yes, but we didn't arrange ahead of. So we'll have to push it back till next Treat Tuesday.
Are we going to make a schedule in here?
Yeah.
Alright.
It was that one thing I forgot to do over the weekend.
Grassy's fault.
No, I'll take the hit on that. Grassy doesn't do Treat Tuesday. He's too good for it. Whoops, that was a big jump. Okay, so you got it all correct, good. Let's try that again. What's f of g? Dan?
2 cosine x minus 3.
2 cosine x minus 3. Well done. Keep going, Dan. What's g of f?
You said cos times 2x minus 3.
Beautiful. Well done. Any problems with that? Put one function into another, you're good to go. Let's move on to something more interesting. Polynomial inequalities. We did a little bit of work with this earlier. I want to come back to it and visit it again because there are probably some techniques you use in pre-calc to solve these that require a little bit of review. One of the steps in solving a polynomial inequality is going to be testing regions. And I want to make sure that you understand how to do each of these separate things. So it's easy to plug a number into your calculator. That's not a big thing. Do you understand what Boolean logic is? Has anybody ever shown you that?
No.
Get out your calculators. This is quite handy and very simple. As an example to practice Boolean logic, we're going to take something nice and easy and say 2x minus 3 is greater than or equal to 4. Okay. And we're going to test a number. Dan, what would you like to test? What number? Get kind of crazy here. Any number.
12.
12. You are a madman. So we're wondering if 12 makes this a true statement. Obviously, you're all bright and you're not going to do this for 12, but if the problem gets more complicated, you might want to use some Boolean logic. Okay, so first things first, store 12 into x. Do you all know how to do that? 12 stow x, and the x button is up on top. It's the x, t, theta, n button. Nothing fancy will happen. The calculator will just say 12. On the home screen then, you're going to type in this exact inequality. Everything 2x minus 3. This can be found under the math menu. I think it's math test. 4.
There ain't no test.
Oh, good English.
There ain't none.
Oh, sorry. I didn't mean to shout here. The test is above the math button.
What?
I'm learning something new.
Secret of life.
One.
When you hit enter, you will only ever get 2 responses. You will either get a 1 or you'll get a 0. You have to remember that 1 is true, 0 is false. What did we get for an answer?
1.
True, because 12 times 2 is 24 minus 3 is 21, which is greater than 4. Oh, Daniel, give me another number, please.
Any number?
That doesn't work, preferably, so we don't repeat the same. Mark, go.
Did you know yours?
You can do whatever you want. This is America. Fight the power right on.
Alright, just do one.
Negative 1.3.
Just one.
Just, alright, negative 1.3.
Wow.
Negative 1.32.
You don't have to listen to him, you
Negative
know.
1.3.
Okay.
Negative 1.4.
Listen to him.
You don't have to listen to him, but you do have to listen to me. All right, test that one. So, wait, before you do it, hold on.
God bless.
When you're testing regions, the inequality could be rather lengthy and ugly. You should know how to pull this up again without having to retype it. So your keystroke would be something like negative 1.3 store x, and then arrow up to the inequality that you already typed in, hit enter twice, and it should spit out
0.
0. Good, because it's false.
Wait.
Wow, but
Arrow. Enter, enter. Whoa, I don't know what you're doing there, girl. You're crazy. There you go. Okay. So the question you have to ask yourself is do I want to go through the hassle of using the Boolean logic on the calculator, or can I just plug numbers in and check them? And we'll take a look at a couple examples and see which one would work best for your needs. Okay, so we'll start with something easy. We got a quadratic. And so first things first, I probably want to move the 3x to the other side. Or I could turn the inequality into an equal sign. Order is not important there. If I move the 3x to the other side, let's talk about what we're doing graphically. I'm looking for where this parabola, by the way, what can you tell me about that parabola? Okay, so do that first. No, let's do one more thing. Nope, I'm jumping the gun here. Take this. It opens up. Good. And if I move the 3x to the other side, I have x squared minus 3x minus 10. It opens up, and we're wondering, where is that thing above the x-axis? Which means we're going to need to find critical numbers. So I did that by factoring it. I'm leaving out some steps, by the way. I have a more complicated problem that I'll go through step by step with you. But is it safe to assume you can all find those critical numbers?
Yes.
Move the 3x to the other side, factor. It factors nicely using the factoring or quadratic formula, whatever it is you want to use. Slap those numbers on a number line and test regions. Now, realistically speaking, do you need to use Boolean logic? I hope not. What would be a good number to pick in the center here? 0. So plug it in up here. 0 minus 10 is, that's negative. Is a negative number greater than 0? No, that's false. What's a good number to pick over here? -3 would work just great. Plug -3 in there, figure it out. As the problems get more complicated, you may find that you want to rely on the calculator a little bit more to test regions. Do not assume that once you test a region that it's always going to flip-flop back and forth. So if you test the first region, you get true, don't assume it's going to go true, false, true. Or if the first one tests false, don't assume it's going to go false, true, false. We're going to look at some bizarre functions that do all kinds of weird things. Is this coming back to you? Good. And then don't forget your answers in interval notation. That's pretty much the AP standard. All right, let's try something more interesting. This will be fun. If we use the same approach we used in the last problem, the first thing I'm going to do is turn that into an equation and solve it. So I get 2 over 2x plus 3 is equal to 2 over x minus 5. How do I solve that? Cross multiply. Be careful when you cross multiply that you put this puppy in parentheses. And so 4x plus 6 is equal to 2x minus ds. So 2x is equal to -16, so x is equal to -8. Critical number. Critical number. Now what? Other way?
That side.
Can you be more specific, Mason?
Draw a number line.
I like that.
5, 8. -8.
I like that even better.
Test for
What number would you like to test over here? -10. Okay, so if I put in -10 over here, I'm going to get 2 over -17.
-20.
No, -17.
Oh, -17.
If I put -10 in here, I get 2 over -15.
Wait, why don't you flip the side?
What's wrong with you?
Oh, never mind.
That's not true.
Am I okay?
Yeah, he's having a rough time.
He's having a rough day, but I'm
Oh, yeah,
good.
you're good.
I'm solid. Okay, excellent. Which number is bigger? Is it a true statement?
No.
Yes.
No.
No, it's not. It's not.
Yes, it is.
Yeah, negative 215 is more negative than negative
Just more and more.
No, it's not.
No, it's not.
Yeah, it
No,
is.
it's not.
How's this?
So it's
Oh, no,
false.
it is. Never mind. False.
Oh.
It's
Negative
false.
217 is closer to 0 than negative 2.
Yeah, Mason.
Are we trusting Mason?
Yeah.
Yes.
He is correct. It's false. What would be a good number to plug in here?
0.
0. If I plug in 0, I get 2 over 3, and I'm wondering if that's less than or equal to 2 over -5. That would also be, uh-oh.
-8.
So negative 8 is the only answer.
No, we missed something. Let's back up a little bit, do some erasing here. You missed something. What did I forget? Slash what did we forget? Slash what did you forget?
When you divide by negative, you flip the sign.
I'm sorry?
You have to flip the sign.
Nope.
We didn't divide by negative. No.
Correct. So -8 is a critical number because it solves the equation. Where else do you get critical numbers?
Oh, don't you have to set the denominator equal to 0?
Lovely. Well done. So not only is -8 a critical number, but we also have critical numbers with x being -3/2 and 5. That changes the whole game. When you're plotting the numbers on a number line, please plot them in the correct numerical order. Which number is all the way to the left?
-8.
I'm sorry?
-8.
Oh, bueno. E?
Trace overdose.
Trace overdose. Your Espanol is muy bueno.
We don't need the test to the left of -3.
No, we argued about that already, and we know that this is false. What's a good number in here?
No, that's also false. 4.
What did we test before?
0.
0. So we know that this is false.
Side.
How about -4?
-2.
-2?
Yeah.
You have a veritable plethora of possibilities.
-1.
You could choose whatever you... Sometimes as a teacher it's really hard not to make comments, but I'm pretty proud of myself that I just let that one go. So if you're struggling with the fractions, if you don't get it, if you're having trouble testing regions, then this might be a point where you pick up your calculator. Store -4 into x, type in 2 over the quantity 2x plus 3, get a value. Type in 2 over the quantity x minus 5, get a value. Then compare those values. The nice thing about the calculator is it'll give you a decimal value, and that's a little bit easier to compare, or people do better comparing them than they would comparing, say, -2/17 to -2/15. So, did you actually test it, or are you just saying true because you think it goes false, true, false, true?
Actually,
False, true, false.
Awesome. What would be a good number to put in here? How much?
5.1.
10.
Try 6.
Sure, let's get crazy. Let's put 6 in there. Is 2 over 15 less than or equal to 2 over 1?
Yes.
Yes, it's true. Okay, now just for giggles, Max, could you give me that answer in interval notation? Oh wait, hold on, I forgot. Are these solid dots or open circles? All of them?
No. 8 and 5. -8 and 5.
Which ones are solid, which ones are open?
-8 and 5 is solid.
8 is solid,
Open.
the other ones are open, because they can never be those values. Back to you, Max, what do you got for me? Parentheses, okay.
Wait, no, bracket.
Brackets.
Ah, there we go.
Brackets. Bracket?
That doesn't look like a
Bracket?
No.
It's bracket. Don't listen.
It's -8 because it's a.
Oh,
solid.
yeah, it is -8, but we still haven't cleared up the bracket slash parenthesis.
Because it's solid on -8, so it includes.
So you're going with bracket.
Yes.
Okay.
Um,
I'll give you the comma. That one was free.
Oh, nice. All right. We go. Okay, I don't know. This is too much pressure.
I understand. Is your self-esteem in danger?
Maybe.
Okay. You want to pet the dog?
Oh, -2, but then parentheses, because you don't include that.
Parentheses.
Yes, they don't include that.
Okay.
I'm not.
He's messing with my
Better than you.
Me?
Yeah.
Okay.
All right, then do parentheses 5, comma.
Comma's free.
And then you can just do infinity parentheses. There we go.
Oh,
Well done. Let's give it up. Even under pressure. Question, sir?
Can you ever have one that's like all true or all false?
Yes.
So when you write just all true.
If it's all true, it would be -infinity to infinity. If it's all false, it would be empty set. This
It's
guy.
really hard to do that.
no.
Okay.
He plays my.
Are there
Right.
times, like,
Go
Are
ahead.
there times that we'll get null set, or like should we always just like go back and like we probably make it the same?
It's possible to get a null set.
Are you gonna do that?
It's not very common, but think about it this way, if I get something like x squared is less than 0, so that one would be null set because there's nothing that satisfies that condition.
But more often than not. we
More
make-
often than not, it's going to be a practical, a real answer. Okay? So again, I wanted to refresh your memory on how to solve those. Now that we have all that under control, let's move on to a big blank screen. To the end of the lesson. Before we move on though, I want to jump back. I should have talked about this before when we're talking about composite functions. The tricky thing that's going to come up for you is determining domains for those composite functions. So if you think of them as you guys familiar with the function machine? You've never seen the function machine before? Okay. So what you might think of functions as machines here. And so it determines what you can put into the machine. So here's my f of x machine. And I put stuff in and stuff comes out. So the stuff I put in is the domain. The stuff I get out is the range. And let's say we have a function like that, x squared. We can put whatever we want into that function because there's no domain restrictions there. What can you tell me about the range that it spits out? It's always positive, 0 or positive. Then, when we take a composite function, we chain on another function. So if I take a g of x here, uh-oh, battery's low. And now we stop working. As you can clearly see, that's g of x. And now 10 showed up. What is going on?
Time. The answer is always time.
I don't know where that came from. Okay, but anyways, now that I plug into g of x, my domain is not all reals because I'm taking what's spit out of the f of x function. And what's spitting out of the f of x function is only positive values. You have to take that into account when you're talking about composite functions. Okay, it's not just free for all where you throw in whatever you want. You're restricted by other things. Okay, we good? Good. Looks like I need to get a new battery. It's completely stopped working. Okay, great. What time we got? Okay, let me stop this recording.